Hey Algebra 1 students, this is the last video for the end of course test review problems. Let's go ahead and get started. Number 51 here, you should have already tried on your own and gotten an answer. Let's go ahead and do it. What is the value of the function? F of x equals x squared minus 2x plus 2 when x equals negative 3. Here all you need to do is plug in this value of negative 3 in for x and then evaluate. The key to this problem, though, is something that I've stressed to you time and time again. When you plug in a negative number and you square it, you need to make sure to wrap it in parentheses. Did you do that? Did you really do that? Then it becomes just an issue of plugging it into the calculator. So negative 3 squared in parentheses minus 2 times negative 3 plus 2, 17. That is easy enough, right? So the answer choice is D. Number 52. We are given a function right here, and we want to generate a sequence of numbers from this function. Now, the easiest thing to do in order to see what the correct answer is to make a table of values. So n is over here, and then k of n, which is a function of n, is over on the right side. Now we're told that the sequence does not begin at 0, so we can assume that it begins at 1. So n starts at 1, and then 2, and then 3, and so on. So n is the sequence of whole numbers. Well, when we stick in positive 1 for n into the function, we get 3 times 1 plus 1, which is 4. So we know that the first number in the sequence is positive 4. Now what happens if we stick in positive 2 for n? Well, 3 times 2 plus 1 is 6 plus 1 is 7. So the second number is 7. You can already mark out answer choices F and J. Now what is the third number in the sequence? Well, let's stick in 3 for n. So 3 times 3 plus 1 is 9 plus 1, which is 10. So you can see that this linear function is generating a list of numbers that increases by 3 each time, as to be expected. So the next number would be 13, number after that is 16, and so on. So what is the correct answer choice? It is G. In number 53, we are given a graph with some points, and we are asked to determine which of these sets of numbers or sets of ordered pairs represents the relation shown in this graph. Now remember that a relation is just a set of ordered pairs. A relation must be ordered pairs, points, or a graph, right, which is just a set of ordered pairs as well. So just from that, we know that answer choice A and B are not correct because these are sets of individual numbers. Now look at C and D. What do you notice is similar and different about C and D? Well, the x and the y values are switched. So basically this question is just testing you on whether you know that a relation is a set of ordered pairs and whether you know how to read your x and y values. You're in Algebra 1. You've been doing this for a long time. You should know that the x value comes first and then the y value, x and then y, right? X is over here and then y is over here. So let's just grab a couple of points here. Like this one is negative 4 comma positive 2. This one is negative 2 comma positive 4, and so on. You can read the rest of these points off. Now of C and D, which answer choice contains these points right here and contains the rest of them? It's pretty clear that it's answer choice C. Okay. Now answer choice B is not the correct one. It doesn't tell you the whole relation. However, answer choice B does tell you something interesting. Answer choice B is actually the domain of this relation, right? Because domain tells you about the set of x values in a relation. So these x values are contained inside this set. However, that's not the whole relation. The relation is the x and the y values as ordered pairs. Number 54 here. Number 54 has some words that you might not be familiar with, but you might be able to figure out what they mean. We're asked to figure out which transformation of these possible choices occurs to the graph of y equals x plus 1 when the equation of the line changes to y equals negative x plus 1. Now, in order to solve this, you might quickly sketch a graph of both functions, or you can graph it in your calculator. So y equals x plus 1 has a y-intercept of positive 1, and it has a slope of positive 1, so the line should look something like this. Now y equals negative x plus 1 also has a y-intercept of positive 1, but the slope is now negative 1. How do we draw a line that has a slope of negative 1? Well, it'll be going downward like this. Okay, so this is y equals negative x plus 1. Now we want to know, what did we do to this line to change it into this purple line out of these answer choices? Well, look at J here. Did we shift the line down 1 unit? No, we didn't. If we shifted it down, the new line would look something like that. But we didn't do that. Did we shift the line left 1 unit? No, if we would have done that, then we would have done it like this, shifting it left. We didn't do that. Did we reflect it across the x-axis? Now, I hope you know what the word reflect means, right? If we would have reflected it, then the line, or if we would have reflected it across the x-axis, then that means that the x-axis would have acted as kind of a mirror to this blue line here, and the new line would have looked something like this, right? It's a mirror image, but that's not what our new line looks like. So the only answer choice remaining is F. The line is reflected across the y-axis. You see that? The y-axis kind of acts as a mirror about which every point on the original line gets reflected, right? Every point on the original line gets turned into its mirror image across the y-axis. In number 55 here, we are given a compound inequality, an absolute value inequality, and we're asked to determine which of these possible inequalities is equivalent to the original one. Now, do you remember how to deal with absolute value inequalities? Probably not, but let's see if this rings a bell. So if you were to solve an absolute value inequality, the very first step is to split the inequality. First step after that is to take whatever is inside the inequality, put it out here, 6 minus 3n, and then keep the sign and the number on the right side of the inequality the same, right? So basically just drop the inequality symbols. Now, to split on the right over here, you're going to have to do two things simultaneously. Keep the 6 minus 3 in the same, but you're going to flip the direction of the inequality symbol. And do you remember the second thing you're going to do? You're going to change the sign of the 27. So it's going to become negative 27. Okay? So this one absolute value inequality is equivalent to these two separate inequalities. Now, once we have that, how in the world do we make this look like our possible answer choices? Let's see here. This part of it, does it start to look like B? Now I'm going to take this over here. Remember that we can rewrite inequalities by flipping everything. So now 6 minus 3n is greater than or equal to negative 27. So I just flipped everything. Now watch this. What if I take this and I put it on top of the 6 minus 3n that's already there? Look at what we have. This is answer choice B. Do you see that? So B is the correct answer. I hope that made sense. Alright, 56 is a pretty nasty one. Here we have a rational expression that we want to simplify. Remember the two steps to simplifying a rational expression? factor everything you possibly can, then cancel. So let's start by factoring this quadratic right here. It's going to be factored using the shortcut. So we can write down that. Let's see, minus 2 plus 1. Will that work? I think so. And then let's now factor this expression. That's going to be x, let's see, plus 2, and then x minus 1. Does that match that? Yeah, I think it does. Alright, now let's finally factor this guy. Now this down here, I hope you recognize that as being a difference of two squares. So the way to factor that would be x plus 2, x minus 2. Alright, now this guy is multiplying what's over here. So another way to write that is as if we just extended the fraction bar here. Right? So this is up here on top of the fraction. Right? I'm just going to move these down here a little bit. Okay. All right. So we have successfully factored. Yippee! Now let us cancel as much as we possibly can. There's an x plus 2 and an x plus 2. Then there's an x minus 2 and an x minus 2. Now what is left over is x plus 1 times x minus 1. Which answer choice does that correspond to? Well, none of them. Gosh golly, we did something wrong, right? No, we didn't. All we need to do is, so the third step here, kind of obnoxiously, after we've canceled, is to multiply back again. Alright, so we are essentially undoing what we just did, in a sense. So we're going to multiply. I'm going to use FOIL. I hope you don't mind. So x times x, x squared. X times negative 1 is negative x. 1 times x is positive x. 1 times negative 1 is negative 1. These two terms cancel out, negative x plus x. So we are left with x squared minus 1. And that clearly matches with F. Number 57. The distance from Earth to Pluto is approximately 4.3 times 10 to the 12th meters away. The diameter of the Earth is approximately 1.2 times 10 to the 7th meters. Approximately how many times the diameter of Earth is the distance from Earth to Pluto? Now, we're dealing with scientific notation here. Really, we just need to figure out how are we going to combine these two numbers to get our answer. Are we going to divide them? If so, which number is on top? Are we going to multiply them? Or what? Right? Well, I hope it's pretty clear that we're going to take this number and divide it by the other number. Can you kind of convince yourself why that is? It's kind of hard for me to explain. But then this just boils down to plugging it into the calculator. So 4.3 times 10 to the 12th divided by 1.2 times 10 to the 7th. Now, what I just typed in here is wrong. I hope that you didn't type this in as well. I am missing something. I am missing parentheses around what's in the numerator and parentheses around what's in the denominator. Okay? If I would have typed it in the way that I had originally, notice how the answer would have been wrong, or it would have been different from what I have here. Okay? These two numbers are very, very different. Here, you can see that the way I typed it in originally, the 10 to the 7th is now being multiplied instead of being divided, like it should be. And that introduces a factor of 10 to the 14, which is pretty big. So this is our answer right here. Now let's turn that back into scientific notation. 3.6 times 10 to the 1, 2, 3, 4, 5. Okay, 3.6 times 10 to the 5, which is answer choice D. Okay, now let's find the sum of these two polynomials. Sum, remember, means we are going to add these two polynomials. So k cubed plus 2k squared plus 1, and then we are adding 3k squared minus 4. So, in order to add these two polynomials, all we need to do is combine like terms. Well, k cubed does not have anything it can combine with, so it's going to stay the way it is. 2k squared plus 3k squared will give 2 plus 3 plus 5 times k squared. Notice that the exponents stay the same. You only ever change the exponents of a variable if you're multiplying them or dividing. And then finally, 1 minus 4 is minus 3. So which answer choice is this? Looks like answer choice G. Now, answer choices H and J both have a 4k cubed. Those were trying to trick you into taking k cubed plus 3k squared, but you cannot combine those into one. They're not like terms. So I hope that you did not fall into their trap. Number 59 here is pretty straightforward. All we need to do is look at the year 1982 and read off the graph what the value of the necklace is. So first of all, 1982 is, let's see, this is 1990. So 1982 is right about here. Then we just go up and read off the graph. So somewhere in this vicinity. And so the value of the graph at that point is about 4,000. So answer choice C is it. Number 60. We are asked to convert 12 square feet into square inches. This is a train track type of problem. The conversion factor that we're going to need to know is the relationship between feet and inches, which you guys know. There are 12 inches in 1 foot. However, we are dealing with square inches and square feet. So how's that going to change things if we try to convert 12 square feet into square inches? Do you guys remember the difference? Well, if we put our conversion factor, let's see, 1 foot on the bottom to cancel out with the feet at the top, and then 12 inches over here. Remember, we must square this conversion factor. So what you would actually need to calculate in your calculator is 12 times 12 squared. You see that? 12 times 12 squared. What is that equal to? 12 times 12 squared, 1,728, which is answer choice H. Number 61 is pretty easy. All we need to do is find the decimal approximation of these three numbers so that we can directly compare them. So let's just go ahead and type them into our TR Inspire. Square root is right here. Square root of 25 divided by 3 is 2.9. Then the square root of 36 divided by 5 is 2.7. Finally, square root of 49 divided by 8 is 2.5. Which answer choice does this correspond to? Looks like B is correct. Number 62 takes you way back to when we studied properties. You can read all this, just a whole bunch of words, but look at this expression right here. 35 minus 35 times 0.20. And then look at this expression right here. 35 times 1 minus 0.20. Now the question is basically asking us which mathematical property says that these two expressions are the same thing. Well, it's kind of hard to tell how you might go from this expression to this expression. It's easier to see how you would go from here to here. What would you do? You would distribute, right? You would distribute the 35 in order to get this expression. So the property that we're looking for is the distributive property. I hope that's what you said. Number 63. We want to figure out which of the following expressions is equivalent to 3 times x divided by the square root of 3. Now we briefly talked about what to do with expressions that look like this. We have a radical in the bottom of a fraction. The square root of 3 is in the denominator. That is apparently, someone said, illegal. It's illegal to have a radical in the bottom of a fraction. Now the method that we use to remove that radical from the bottom and put the radical on the top, where for some reason it's okay to be, is to multiply the top and bottom of this fraction by the radical that's in the bottom. So if we multiply the bottom by square root of 3 and the top by the square root of 3, and we separate the two with a fraction, right, because this whole expression here is just equal to 1, and we're multiplying by 1, which is okay, right? Doesn't change the essence of 3x divided by square root of 3. This is going to be equal to, well, let's look at the bottom. Square root of 3 times square root of 3. Do you know what that is? This is just equal to 3, positive 3. And then what's left over on the top? 3x times square root of 3. Now one last step. Notice that we have a 3, which is outside the radical on the top, and a 3 outside a radical on the bottom. Hey, cancel those out. So what's left over is x times the square root of 3, which is answer choice D. Number 64. I'm going to make a quick sketch here so that we can kind of visualize what's happening. That is an awful x or y-axis. Positive 3, negative 2 is right about here. And then positive 7, positive 6 is right about up here. Now we want to know what is the distance between those 2 points, right? What is the length of the line segment with those endpoints? Now, do you remember how to find the distance between 2 points? Well, we need to figure out what is this distance. So what is the difference in the x-coordinates of the 2 points? So let's find that first of all. 3 and 7, right? So the x-coordinate here is 3, x-coordinate over here is 7. That means that this distance must be 4, right? 7 minus 3. Now let's try to figure out this distance right here, which is the difference in the y-coordinates. Well, the y-coordinate down here was negative 2. The y-coordinate up here was positive 6. So how long is this line segment? It is positive 8, right? Do you see that? So now we have the 2 legs of a right triangle, and we want to find the length of the hypotenuse, c, so we need to call upon the services of the Greeks. A squared plus b squared equals c squared, the Pythagorean theorem. So we know that 8 squared plus 4 squared equals c squared, 64 plus 16 equals c squared, 80 equals c squared, so c is equal to the square root of 80. Well, unfortunately, none of the answer choices is the square root of 80, so we have to simplify this radical. Remember, the way to simplify, well, one thing you could do right now is just simply find the decimal approximation of this. Let me show you how to do it that way. Find the decimal approximation of square root of 80, 8.94. So c is approximately equal to 8.94. Then just go up to all these answer choices and find their decimal approximations. So 2 times the square root of 21. No, that's not it. How about 2 times the square root of 29. No, that's even bigger. How about 4 times the square root of 3? No, that's too small. That must mean that 4 times the square root of 5 is it. Okay? You see that this number matches that number. So the correct answer choice is 4 times the square root of 5, which is J. Last problem. Woohoo! Now in this problem we are asked to basically factor this expression. And remember that factoring this expression, we can use the shortcut here, would be essentially asking what two numbers multiplied equal 100 and add up to equal 20. And then you could go from there. However, I'm going to work it in a slightly different way. I'm going to work it in a way that you might work it out on the test in case you forget how to factor, which is backwards, right? So I'm just going to pick some answer choices and multiply them. All right, so let's check D. All right, so let's check D. N minus 20 times n minus 5. Let's multiply that to see if we get the original. So I'm going to use FOIL, which means multiply the first two terms, n squared, multiply the outside terms, negative 5n, multiply the inside terms, negative 20n, and then multiply the outside terms, positive 100. Then we simplify the middle two terms, which is n squared minus 25n plus 100. Is that equal to the original expression? Why, no, it is not. So D is not correct. And you could do this for the rest of them, but it turns out that the correct answer choice will be A if you multiply that out. Finally, we're done. You've made it. I've made it. That is it for these videos in which we work out the practice problems for the Algebra 1 EOC. You are now ready for the EOC, and you're going to blow it away. You're going to do phenomenal. This is Mr. Wilsey signing off.